Did you know that over 40% of internet users worldwide use ad blocking services, which can prevent your analytics events from firing? For example, if I visit Airbnb.com and I refresh the page, you can see that my ad blocker is automatically blocking requests to GoogleAnalytics.com and GoogleTagManager.com. That means they're not getting my data. Depending on your particular user base, the actual percentage may be higher or lower than 40%. But either way, there's a good chance you're losing a lot of data to ad blocking software. In this video, I'm going to be showing you how to get your analytics events past ad blockers by using a technique known as monkey patching. But first, what is monkey patching? Monkey patching is a way of dynamically modifying your code at runtime. Let's take a look at an example. In this example, I have a simple class dog, which has a single method getName, which returns a hard-coded string of Tucker. If I create a new dog instance and call the getName function, you can see that Tucker is returned as expected. Now let's assume that this class is part of a third-party library we're utilizing, and we want to modify the behavior to allow for a new name to be assigned to dogs. Since we don't own the underlying code, we can't easily modify the class definition. This is where monkey patching comes in. We can instantiate a new dog object and replace the getName function with a new function that returns a new name, allowing us to redefine the behavior of the third-party code. Another example that might seem more useful is monkey patching the instance to enhance the existing functionality. So in this example, we create a new dog and grab a reference to the current getName function and reassign the getName function again. This time, however, we record the start and end execution time before returning the result. In this example, I added a large loop of no ops so that the time differential would be more noticeable. Now when we run getName, the correct result is still returned while also recording the time elapsed during that function. At this point, you may be thinking this was a lot of effort, and it may have been easier to achieve this using inheritance by creating a new class that extends dog. While I could argue the benefits of composition over inheritance, I don't think it's necessary because inheritance only helps you if you're in control of the instantiation of these objects. One example of an object that cannot be modified using inheritance is the window object from your browser because it's automatically instantiated for you. A popular type of monkey patching called polyfilling updates the window so that older browsers like IE11 can support newer browser APIs like Fetch. We can also apply a previous monkey patch to the window fetch API to automatically track the length of time of our network requests. But the more exciting application, which I think you may be waiting for, is getting your analytics events past your users' ad blockers. Before getting into that though, we'll need some extra context knowledge. First, how do ad blocker services work? Well, from what I've seen, most of them are just simple domain and URL blacklists. So for example, if your browser sees a request to analytics.google.com, it's going to automatically block that request. Now let's go over the user flow in a typical application when there are no ad blocking services present. I'll only be going over Google Analytics specifically, but the same approach I use in this video can be applied for any service you have that might be getting lost due to ad blocking services. First, a browser will request some page from your web server. Your web server will then return with a response that has some HTML, a body, yada yada, and more importantly, a script tag that references the Google Tag Manager. This tells your browser to fetch some JavaScript from the Google Analytics server. The JavaScript code returned sets in motion a lifecycle that will hit a number of different services over the course of a user's visit, such as analytics.google.com, googleanalytics.com, stats.g.doubleclick.net, etc. The problem is, if the user's browser has ad blocking enabled, each one of these requests will be inspected by your ad blocker, and because all of these servers are well-known tracking servers, your ad blocker will automatically block these requests. So how do we get around that? The answer here is standing up a proxy service. We can set up a brand new server hosted from our own URL and domain, which isn't listed anywhere as a well-known ad server, where we can proxy any necessary requests that would otherwise be ad blocked. Taking a look at the original diagram, there are two types of requests that we need to proxy. The original script tag, which kicks off the Google Tag Manager lifecycle, and the requests that are made to a number of different analytics servers as part of the lifecycle, like googleanalytics.com, analytics.google.com, etc. The script tag is easy enough to proxy with Express or Web API routes. Simply fetch the original Google tag URL from your web server and return the response. Then in your web app, find the Google Tag Manager script and replace the source with the location of your new server. The requests to other analytics servers are more difficult because we don't know the exact form each request is going to take, and the URIs aren't readily available via a script tag like before. Instead, these requests are fired through browser APIs like fetch, XML HTTP requests, and send beacon. Remember that the idea here is to proxy these requests through our own servers. The best way I can think to do that is by monkey patching those browser APIs. By rewriting the built-in functions used for network requesting, we can ensure that any requests to known analytics servers are rerouted to our own URLs where we proxy the request to analytics servers. The implementation of this is a bit more complicated than the first proxy. First, we need to monkey patch each of the browser APIs used for network requests to rewrite URLs. For convenience, I wrote a helper function to monkey patch fetch, XML HTTP request, and send beacon with an arbitrary URL rewrite function. You can design your URL rewrite however you want, but for simplicity, I am going to rewrite the request to known analytics servers to my own URL where the original request's origin URL is encoded as part of the path. For example, a request to https analytics.google.com/g/collect/xyz would result in a request to my own server where you can see https://analytics.google.com is encoded as the first part of the path. Next, you'll want to compile your code using a tool like Rollup or Webpack and minify it using a tool like Cursor. This ensures that your monkey patching has a minimal impact on your website's performance. Finally, you'll want to inline the script so that it's included in the initial HTML response. The easiest way to inline your script is to use the raw loader Webpack loader. From our server, we can parse the encoded URL and proxy the original request to the analytics server. In this example, I use a well-known library HTTP proxy for creating the proxy request. You should make sure to validate requests coming into your proxy server so that nefarious users can't use it for malicious purposes. Finally, for Google Analytics to pick up the proper geolocation data, you must parse the originating IP address from the request and pass it as a URL parameter as part of the proxy request. Otherwise, the Google Analytics platform will use the IP address of your server for all proxy requests. Now that we've wired all that up, we can take a look at it in action. If we take a look at the site I have this code hosted on, we can see in the developer console that I have a script tag loading the initial Google Tag Manager script at API/gtaganalytics, and subsequent calls that are part of the Google Analytics lifecycle are successfully proxied through my own server without being blocked by my built-in Adblocking. So that's really cool. We went from losing a ton of our analytics to Adblockers to losing almost none. But there are a number of things that could be improved upon. A simple optimization would be caching the initial Google Tag Manager script. Another improvement to make the proxying more discreet would be to assign random strings to each of the analytics servers so that your proxy requests no longer include analytics.google.com in the URI. Finally, you probably don't want to pay for all the traffic going to analytics servers if you don't have to. You could improve the existing monkey patching of network requests to only proxy them if the browser has ad blocking enabled. So to recap, we wrote a monkey patching script so that we could hijack the default behavior of browser APIs like window.fetch, XML HTTP request, and send beacon. And second, we set up a proxy server so that we could send analytics events without being blocked by ad blockers. Hopefully now you have an idea of how you might get your analytics past ad blockers in your own app. You've made it to the end of the video, so if you wouldn't mind smashing that like button, I'd really appreciate it. Catch you in the next one, and as always, the code will be linked in the description. Have a good one.